Hello. Okay, so this is the heat of fusion lab. Okay, so here's how this works. Heat of fusion is just a big fancy way of saying, how do we tell how much heat is needed to melt ice? It might not seem like a big deal to you, but for climate change and glaciers and things like that, people are kind of curious about that. One of the ways you can think of heat as think of it as like it's similar, or an analogy is like having money in a bank account. That as we transfer to different accounts, we can actually withdraw it, and then that money can actually do something for us. Heat does the same thing. It flows from one place to another, and it actually has to do work on something. Okay, so that's what we're trying to figure out. How much work does it take to melt ice? Okay, so here are the things that you're going to need. You're going to need one of these. Okay, this is a vernier probe that you need to attach right to your computer. You also need to have the graphical analysis or the app in your Chromebook. We're going to have a bunch of ice. We're going to have a cup like this for the hot water, the lid right here. This is called a calorimeter or bomb calorimeter. It just keeps all the heat exchange in here. And we're going to need a graduated cylinder. So how do we do this? I have a coffee pot that will get a known amount of hot water. Put it in the grad cylinder. You want to pour it into the cup. Put the lid on. Got it. Stick the thermometer in there and get the temperature and the volume of the warm hot water. Number one. That's where our heat is current. That's the savings account that our heat is being stored in. Now the heat is going to transfer into something. That's what the ice is. Okay. So what you want to do is you take your ice like this. Just grab it. It won't kill you. Dump it in here with the hot water. Cap it because we want all of the heat exchange to stay in here. Take your thermometer plugged in recording, and you want to put it in and just stir it. Okay. And what you want to do is record the temperature you started at, and then and you keep on adding ice until it gets anywhere between 0 and 4 degrees Celsius. So we're trying to cool the water all the way down. Once it gets to 0 and 4 degrees Celsius, the instructions say you need to remove the ice with tongs. You can try that if you want. Here's what I found. The best way to do it is use these as your tongs. You basically stick your hand in, get the excess ice, try to drip it out, and then toss the ice down the sink. Save the water. Okay. Now what we'll do is we're going to take all of this water and get a measurement. Word of caution. Okay, if you started out with 100 mils of warm water and you had the ice melt, you're going to have more than 100 mils of water. And the reason I say this is because I've seen a number of students over the years pour this in and just have this overflow. So you may need to make several measurements, right? So you can count on it being more than 100 mils of water. That more is the ice that was melted, and the heat from the warm water did the work on the ice to physically change the potential and kinetic energy of those particles. It did work on it, and to cool things down. So, and in this case, yeah. So the heat from the warm water flows to the ice. First, it goes from a solid 0 degrees Celsius to a liquid close to 0 degrees Celsius. And that's not something that's necessarily recorded by a thermometer, but that's a change in state. Okay. And our goal is to figure out, well, how much energy does it take to do that? Okay. So that's it. Good luck. And if you have any questions, let me know.